Hello students, in this video we will see fourth numerical of exercise of chapter 5. The question is, a short bar magnet of magnetic moment 0.32 joule per Tesla is placed in uniform magnetic field of 0.15 Tesla. If the bar magnet is free to rotate in the plane of the field, which orientation would correspond to its stable and unstable equilibrium? What is the potential energy of the magnet in each case? So let us first try to understand the situation before undergoing any calculation part. Let us assume that this is the uniform magnetic field. So field lines are going from left to right. Now for magnetic field lines to go from left to right, uh, we must have north pole of external magnet on left side, isn't it? And south pole on right side. So we may say that there is large north pole on left side and large south pole on right side. Only then we can have this type of uniform magnetic field. Now consider different situation. Let us assume that we have bar magnet placed in in this orientation with say north up, south down, or else let me consider the bar magnet to be like this, where I have north on the right side, south on left side. We may consider the other possibility also, where bar magnet is having north pole downward, south pole upward, or else we can assume that magnet is placed in such a way that north pole is on left side, south pole is on right side. So for this four possibility, let us label them as 1, 2, 3 and 4. What is the angle in first case? Angle between magnetic field and the dipole moment. So in first case, dipole moment from south to north, and here is the magnetic field. So what is the angle? Theta is 90 degree. Okay. In second case, magnetic moment is from south to north, and field is also in the same direction, so theta is 0 degree. In third case, if I consider dipole moment from south to north, then look at the angle. Angle is this, and it is 270 degree, or else you may say minus 90 degree. And in last case, dipole moment from south to north, magnetic field is going in opposite direction, hence theta is 180 degree. Okay. Now, out of this four, in which situation magnet is comfortable? Most comfortable situation for the magnet is this, isn't it? Given choice, magnet would not like to change its orientation, and hence it is called stable equilibrium. Whereas in fourth case, the magnet cannot move by itself, but if it is disturbed, it would not come back to this orientation again. So it is called unstable equilibrium. Whereas in first and third case, magnet would rotate by itself, it will experience torque, and it will settle down to second situation. So which is the minimum potential energy configuration? It is second one, and fourth one is the maximum potential energy configuration. The magnet is not very much comfortable, and hence potential energy in fourth situation is maximum. It is unstable equilibrium, right? Now what is the data given? Data is dipole moment we are given, it is 0.32 joule per Tesla, and uniform magnetic field is having intensity of 0.15 Tesla. Okay, and potential energy we are asked to find out. So what is the expression for potential energy? U is minus m dot b, or else you may say potential energy is minus mb sine theta. So when you take theta to be 0 degree, and if you use this formula, equation 1, you will get potential energy corresponding to minimum potential energy, stable equilibrium, and if you take theta to be 180 degree, you will get potential energy corresponding to unstable equilibrium or maximum potential energy. I would like to add one more point here, which is not asked, but you may be asked, that if we have to take the magnet from fourth situation to second situation, how much work we'll have to do? So in that case, the difference of potential energy is U4 minus U2. And if you are taking it from second to fourth, sorry, my mistake. Suppose if you are taking the magnet from second situation to fourth situation, then final potential energy minus initial potential energy is the work done. And if you are taking it from fourth situation to second situation, the work done is U2 minus U4. Try to find out and see one work is negative, other work is positive. Why it should be so? Ponder over it. Thank you.